Welcome to episode 17 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data and AI with you.
And I'm Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Today, we're diving into something big but often overlooked, JSON.stringify. Sounds techy, right? But it plays a key role in how data is handled in AI.
Absolutely, Jonas. JSON.stringify might sound like a function only programmers care about, but the way data gets packaged and shared affects how AI systems work in the real world. Let's unpack it.
Let's start simple. JSON.stringify is a method in JavaScript that turns a JavaScript object, think of it like a data container, into a JSON string. JSON stands for JavaScript Object Notation. It's a lightweight format used to store and exchange data.
Right, and why does that matter? Well, in many companies, data comes from lots of sources, sensors, apps, databases, and each might speak a slightly different language. JSON acts like the universal translator, putting data into a standard readable text format.
Exactly, Amy. To give an analogy, imagine you have a huge box of Lego bricks of all shapes and colors. JSON.stringify takes your entire Lego creation, the complex structure, and flattens it out into a photo or blueprint, a simplified text version. That blueprint can then be sent anywhere, understood, and rebuilt.
And from my consulting days, that's crucial during data integration projects. One example is in healthcare. Hospitals collect patient data with all sorts of formats. To move that data between systems, they use JSON. When a lab system exports test results, JSON.stringify converts the data into a neat, standardized package. Then a doctor's application can read it, no matter who made it.
Good point. This serialization step, turning data structures into a string, is essential for storing data, sending it over a network, or saving it in files. It's not just JavaScript either. JSON is language agnostic and widely supported.
But there are challenges. If JSON.stringify doesn't handle data correctly, say it misses nested objects or converts dates improperly, then your AI system might end up with incomplete or corrupted data. That means bad insights.
That touches on an important theoretical aspect, data integrity. Serialization needs to preserve the exact information and structure. If you think about training a machine learning model, feeding it partial or mangled data is like teaching a child with wrong facts. The model learns incorrectly.
In the automotive world, I saw this firsthand. A client was streaming real-time car sensor data to their AI diagnostic system. They used JSON.stringify to package sensor readings, but some numerical values were strings because of a serialization glitch. The AI flagged false alarms. Costly recalls almost happened before they traced the issue back to how the data was stringified.
This example also highlights data types in serialization. JSON supports basic types, strings, numbers, arrays, booleans, null, but doesn't natively preserve functions, undefined values, or certain object types. So sometimes developers have to build custom replacers or handlers to ensure all needed data survives the process.
And that's where consulting comes in. I help companies audit their data pipelines to make sure serialization and deserialization, the reverse process, are aligned. Otherwise, you're at risk of data loss or misinterpretation.
Let's talk about why JSON.stringify is preferred over other formats like XML or CSV in AI workflows. First, JSON is human readable, much easier to understand and debug.
Plus, JSON structures data hierarchically. If you think about customer data, it's not just flat rows. You have orders, products, payment details nested inside. JSON captures this complexity smoothly, which is critical for AI models needing rich context.
Historically, JSON became popular in the early 2000s thanks to its easy use in web development. But its rise parallels the growth in APIs, application programming interfaces that let different systems talk to each other.
APIs are the backbone of modern AI applications. For example, a retail chain I worked with used JSON-based APIs to connect inventory, customer feedback, and sales systems. By stringifying data into JSON, they could push updates instantly to an AI recommendation engine, which then adapted marketing campaigns in real time.
On a more conceptual note, serialization like JSON.stringify is one of the pillars of distributed computing. When AI systems run across multiple servers or cloud instances, data has to be sent back and forth efficiently and reliably.
That's why performance matters too. JSON.stringify is fast and lightweight, but I've seen cases where huge data blobs get overstringified, slowing down AI model refreshes. Sometimes teams switch to binary serialization, like protocol buffers, for efficiency.
True. Each serialization method has trade-offs. JSON prioritizes readability and flexibility at some cost to speed and compactness.
I think what's fascinating here is that something as simple as JSON.stringify is a critical gear in the AI machine, unnoticed but unstoppable.
Indeed. Before we wrap up, let's also mention that JSON.stringify accepts optional parameters to control formatting, spacing for readability, or a replacer function to customize what gets serialized.
That can help with privacy too. Say you want to exclude sensitive fields before sending data to an AI partner. A replacer function filters those out during stringification.
Great practical tip, Amy. To summarize then, JSON.stringify is the bridge between complex JavaScript objects and the universal JSON text format. It's central for data exchange in AI systems.
And from my side, making sure this serialization is done correctly keeps your AI reliable and trustworthy. It's a small step with big consequences in real business environments.
Key takeaway? Serialization with JSON.stringify transforms data into a shareable, standardized format, enabling AI systems to communicate and learn effectively.
And in the messy real world, mastering this step avoids costly errors, improves integration, and powers smarter AI-driven decisions.
Next time, we'll explore data labeling, how humans teach machines to see, hear, and understand the world. It's the secret sauce behind many AI breakthroughs.
If you're enjoying this, please like or rate us 5 stars in your podcast app. Drop your comments or questions. We'd love to feature them and help you get even more out of AI and data.
Until next time, stay curious, stay data-driven.